Section 3.4, proofs with perpendicular lines. The distance from a point to a line is the length of the perpendicular segment from the point to the line. Example 1. Find the distance from point A to point BC. So from point A to the line BC, again, we're going to take the perpendicular segment. So we're going to take this one here. So we're going to find the length of AD. So we're going to call this one x1, y1, x2, y2. And we're going to find the length of AD. And let's go ahead and use the formula this time. We can still do the same thing that I've been doing, but let's just mix it up. So we're going to say -4 minus -1 squared plus 2 minus 8 squared, which will give us -4 plus 1, which will give us -3 squared. Notice how I put it in parentheses again. Plus 2 minus 8 will be -6 squared. If you don't put it in the parentheses, ladies and gentlemen, again, remember, it will just take it as -36, not positive, because a negative times a negative. So put it in parentheses. So if we do that, we'll get -3 squared is 9. -6 squared is 36. So that will give us the square root of 45. And they've been asking us to go to the nearest tenth. So let's go ahead and do that on this one. And you'll get -6.7. All right. So now the next one is we have a couple of things to talk about. So the perpendicular bisector of a line segment PQ is the line N with the following two properties. N is perpendicular to line PQ, or in this case, line segment PQ, and N passes through the midpoint of PQ. So what does it mean when it passes through the midpoint? It tells us then that PM is equal to MQ. All right, so now we're going to use some of these things to help prove some of our theorems. So proving theorems about perpendicular lines. Theorem 3.10, linear pair perpendicular theorem. If two lines intersect to form a linear pair of angles, remember what a linear pair is, all right, of congruent angles, then the lines are perpendicular. So what it's telling us here is if, remember a linear pair is they equal 180, and they're telling us in this case if angle 1 is congruent to angle 2, then you know that line G is perpendicular to line H. Theorem 111, 3.11, perpendicular transversal theorem. If in a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So what this one's telling us on this one is if H is parallel to K, which again we should know because we see that we have those two arrows there, so we know that they are parallel. So if H is parallel to K, and you can tell that J is perpendicular to H, again by the box there, and it's saying if it's perpendicular to that one, then we know it has to also be perpendicular to line K. So J is perpendicular to K. And then theorem 312, lines perpendicular to transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So on this one here, what it's telling us is if M is perpendicular to P and N is perpendicular to P, so they're perpendicular to the same line, then we know that M is parallel to N. All right, pretty straightforward. Again, we're not doing as many proofs, but I still like to show you one every once in a while. And let's go ahead and work this one out. So we're going to prove that line's perpendicular to a transversal theorem. All right, so again, let's do our statements and our reasons. And the first one we should always write is what we're trying to, is our given. So we're going to say that M is perpendicular to P, and N is perpendicular to P, again, by our given. And what do we know when they're perpendicular? We know that they're right angles, so we can say that angle 1 and angle 2 are right angles. And what do you think that is? What did I just say on the first one? M is perpendicular to P, and N is perpendicular to P. So I use the word is. So we can say by definition of perpendicular lines. And since we know that they are right angles, we can now state that angle 1 is congruent to angle 2. And again, because we know that all right angles are congruent. And then finally, again, if you think about what we just did here, so we just proved that those two are right angles. And if we look at it, I have an F there. And with that F, it looks like it's on the top of them. So F are corresponding angles. So we can state then that M is parallel to N by the corresponding angles converse. Okay. And our last thing here, determine which lines, if any, must be parallel and explain your reasoning for A. So let's see, we have R and R is perpendicular to P and R is perpendicular to Q. So the only thing we can state then is that P is parallel to Q. Again, we can say that because since P is perpendicular to R and Q is perpendicular to R, lines P and Q are parallel by lines perpendicular to a transversal theorem. I don't know if you can hear that, but that's my dog drinking his water out of his bowl. Sounds really loud to me. B, let's look at it. Well, all we can see is that one's perpendicular. We don't know that Q is perpendicular. So on this one here, we can only say it's none, because the only thing you can say is that P is perpendicular to S. And finally, on the last one here, looks like it's telling us a bunch of things. It's telling us that 1 and 2 are a linear pair. It's telling us that M is perpendicular to S and N is perpendicular to T. So what can it tell us all? It can tell us that S is parallel to T and M is parallel to N. Let's see, this one's going to be a little involved, but we can say that angle 1 is congruent to angle 2. So N is perpendicular to S by the linear pair perpendicular theorem. Okay. And then because N is perpendicular to S and N is perpendicular to T, we can state that S is parallel to T by lines perpendicular to transversal theorem. All right, so I just showed you this one here. And then we can say because M is perpendicular to S and N is perpendicular to S, M and N are also parallel by lines perpendicular to a transversal theorem. So kind of wordy, ladies and gentlemen, but remember, with our homework, it would probably be a drag and drop one. So guess we'll see when we finish our homework. Thanks.